Throw away. Well, that's the way we say hello in Bulgaria. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of physics. Now, children, can you see this picturesque place? I'm sure you're going to visit this soon. This is Seven Rila Lakes, Dangskia, Bulgaria. Mythology has it that there were two giants, a male and a female, who used to live here peacefully. The evil spirits were envious about this, and they brought about earthquakes and all devastations which were possible. The male giant fought it all out, but sadly lost his life. The female giant was so sad that she cried and cried and cried, and with her giant capacity she filled up 7 lakes. They exist till date. These are the 7 Rila lakes of Dangskia, Bulgaria. Make sure you visit this lovely, fantastic, serene place and have a nice time here. But do not forget to have the local Bulgarian food, which is really awesome, Tivanik. And also to tell all the people of Bulgaria that you get to meet, Stroway. In this note, children, I'm going to start off this lecture of electrical resistance. Now remember, children, that whenever there is a metallic atom, there are electrons which are something like this, right? That is, they are in these shells which are around the nucleus, which contains the protons and the neutrons, which are very tightly bound together with the nuclear force. But these electrons have a lot of space, right? That is, most of it is empty space when you talk about a complete atom, as nucleus is confined in a very small space and the electrons have a large amount of space. Now when we talk about the electrons which are in the outermost electronic shell, then they are at a large distance from the positively charged nucleus. As such, they are relatively free of the Coulomb's force of attraction. And that is the reason why these free electrons move about the whole of the metal space and thus form a lot of free electrons which are easy to move from the negative potential to a positive potential. That means from excess to deficiency when there is a potential difference which is created in a circuit. Now children, when we talk about these electrons, for them to pass about within the metal is not that simple, because whenever we have these electrons, initially these electrons, when they are within the neutral conductor, when they are not put in contact of some potential difference, then these electrons, they collide among themselves, they collide with the positively charged nuclei, but obviously they are not moving in a specific direction. But when they are put in potential difference, then what happens is they have to move this strong crystal lattice which is different in every case. Like here you can see that if we talk about the different metals, the different metal atoms, they are having different sort of a configuration within the whole metallic space. So when these electrons, they pass having a potential difference, they move from a lower potential to a higher potential, and in moving so they have to collide against all of these positively charged ions, right, which are the positive metallic ions. And as they've been accelerated due to this electrical force caused by the potential difference, they are moving with an acceleration. However, they are caught up in the space of moving with the positively charged ions and thus are retarded. Their energy is lost. But again, as the force is still acting, so they again start with an increased speed towards the positive terminal, and in doing so their speed is again and again decreased, further increased, decreased, increased, and so on. As such, they don't move with a constant speed or they don't move with an acceleration. However, they're just trying to drift from the negative potential or from the lower potential to the higher potential due to the potential difference which is created. And this speed is thus known as the drift velocity. Right now, children, when we talk about these electrons, as you see, they are continuously having collisions with the positively charged ions. Right, and this collision causes some obstruction which is known as the electrical resistance. Normally the passage of electrons is in the external circuit, where there is the movement of electrons due to a potential difference maintained between the two electrodes, that is the negative electrode and the positive electrode, as we discussed an electric cell in the last lecture. Now, children, when we talk about thus this electrical resistance, it is there in the external circuit, right? So we can now define it that when we talk about the external resistance, it is the obstruction which is offered to the flow of electrons in the metal conductors which are carrying the electrons. Now, further, children, when we talk about this electrical resistance, there are certain factors on which this electrical resistance depends. Next, now we'll be discussing those factors. So if you talk about the formula, children, that we talk about when we talk about electrical resistance, we normally talk about the formula to be R is equal to rho L divided by A. Right now, children, here if we talk about this rho is the specific resistance. What is it? It is the specific resistance. Right, remember, children, this is also known as the resistivity. Right now, if we talk about this L is actually the length of the wire. Right, so whatever wire is making the electrons to flow from the lower potential to the higher potential, or from excess of electrons to deficiency of electrons, right, that length of the wire is this L. Right, further, if we talk about this capital A, this capital A is actually the area of cross section of the wire. Now, whenever we talk about these wires are normally cylindrical wires. So if we talk about the area of cross section, the area of cross section is a circle. So if we talk about the area of the circle, as we know it to be pi r square, so this area of cross section normally will be pi r square. So what becomes effectively important is the radius of cross section. So more will be the radius of cross section, right? More will be the value of pi r square, or the area of cross section is going to be squared with the value of the radius of cross section. Right now, children, let's discuss each of these factors one by one. So first, children, is what is specific resistance. Now if we talk about specific resistance, children, remember the specific resistance is one which depicts the nature of the metal. I'm sure you people must have seen here that whenever we talk about this metal space, right, the metal space is actually this crystal lattice. Are you able to see this crystal lattice? So this crystal lattice differs with every metal, right? As you see here, that if we talk about metals like iron, right, chromium, etc., then they have a crystal lattice like this. Now if we talk about metals like aluminum, nickel, then copper, right, gold, etc., they have a crystal lattice like this. Now if we talk about some other metals, like if we talk about titanium, zinc, magnesium, cadmium, then they have a crystal lattice like this. So for different metals there are different crystal lattices. Now when electrons are to pass through, they are actually to pass through such crystal lattice which exists within the cylindrical wires. As such, the different type of collisions that they will have will be different. Remember, here we talk about another variable which is known as tau, that is the time interval between any two collisions, right? So whenever there will be collisions, so there will be a variable, right, which is the time interval between any two collisions. So when we talk about the nature of a conductor, right? That is when we are talking about rho, right, which is the specific resistance or the resistivity. It actually tells you about two things primarily. One is the number of free electrons which are possible, right? So obviously, as we know that the outermost shell will have different number of different number of electrons. As such, the number of electrons which will be free for different metals are going to be different, right? So the nature or the specific resistance will primarily depend upon more number of free electrons. So more will be the number of electrons which will be free, lesser will be the resistance, right? So that is the concentration of electrons, or the number of electrons which are present in that specific metal is something which is very important. More will it be, right? Less will be the resistance. Now the second thing is the time interval between two collisions. That means if more be the time interval between two collisions, obviously less will be the number of collisions, isn't it? So if the time interval is more between collisions, right, it is expected that the number of collisions will be less. And if the number of collisions is less, then obviously the resistance offered is also going to be less, right? So these are the two important things which tell you about the nature of the substance, right? So the nature of the substance depends primarily upon this lattice and also upon the number of free electrons which are available. Now the next thing, children, is we talk about the length of the wire, right? Longer be the length of path which a electron has to travel, then obviously the electron will have to face more number of collisions, and more be the number of collisions, right, greater will be the resistance. And that is the reason when we talk about the resistance, it is directly proportional to the length of the wire. That means longer be the length of the wire, more will be the resistance which will be offered to the flow of electrons. Now this being the second factor, now we talk about the next factor, which is the area of cross section. So now, children, if we talk about the area of cross section, you can imagine that we can talk about the area of cross section to be, say, something like this. That is, we can talk about a circular space, right? So let's say now that we talk about a circular space, say something like this, right? So you can imagine here that if this area of cross section is lesser, right, then what will happen is the number of collisions, right, because the area is less, so obviously the number of collisions will be more, right? And if the area of cross section is more, that means there is the wire which is more thick, there is more amount of space through which the electrons can pass through, so obviously the number of collisions is going to be reduced. So if we talk about two type of wires, say one which is less thick and the second which is more thick, you can easily imagine that the one which is going to be more thick or which has a greater area of cross section will be able to give more amount of space for the passage of electrons. And as there's going to be more amount of space for the passage of electrons, so the collisions are going to be less, and as such the resistance is also going to be less, right? So thus here we have the next factor, which is capital A, which actually depicts the area of cross section. This is the third, and as you can see, the resistance is inversely proportional to the area of cross section, right? So this is the next one. And finally we have one more factor, which is the temperature, right? So if we talk about the last factor, children, the last factor is temperature. Now, as you know that whenever we talk about temperature, temperature is actually the average kinetic energy, right? I'm sure you people know what kinetic energy is. It is half mv square. That means when a particle or when a body is in motion, right, then we talk about the energy that it has due to its motion, right, to be the kinetic energy. Now, when the temperature increases, the average kinetic energy of the particles will increase. So if the temperature of the electrons which are moving from a lower potential to a higher potential will increase. They will start moving randomly because they get more energy, and when they start moving randomly, there will be more number of collisions. And that is the reason when the temperature of a wire increases, the number of collisions also increases. As such, the resistance of the wire will also increase, right? So this is a group of 4 factors on which the resistance depends, right? I will quickly discuss all of these all over again so that if there is any confusion, all of that gets cleared. So first, children, we'll start off with what we started with. We first started with that if suppose we talk about an atom of a metal, right, then an atom of a metal has the speciality that the electrons in the outermost shell are the ones which will come free because they have a large distance from the positively charged nucleus. As such, they become relatively free from the Coulomb's force of attraction, and thus they start moving about the metal space. When they start moving freely in the metal space, they have collisions with the fellow electrons, and also they have collisions with the positively charged nuclei. But that is not that important. But when there is a potential difference, then these electrons, they start moving from the lower potential to the higher potential, and when they start moving from the lower potential to the higher potential, then they start colliding with the positively charged ions, that is the positively charged nuclei, right? And as they have large mass, so these nuclei, they impede or they deaccelerate the electrons. The electrons having some acceleration towards the positively charged electrode, right? And as such, they don't move with acceleration continuously as they collide with the positively charged nuclei. Thus, they are retarded as the force is still there, so they again accelerate, right? Then again they collide and their velocity decreases. As such, there is a continuous drift of electrons towards the potential difference, and this is the reason why the speed of the electrons is known as drift velocity, right? Next, now children, after this we discussed another concept, that is when we talk about these electrons as they are having collisions with the positively charged nuclei, thus there is some obstruction which is being offered to the passage of electrons. This obstruction which is offered to the passage of electrons in they moving from a lower potential to a higher potential or in the direction of the potential difference, right? They have a resistance which is known as the external resistance, as this is the resistance which is there in the wires which conduct the electrons. Next, now children, when we talk about this external resistance, this depends upon a few factors. The first factor was the nature. Now, the nature was depending upon 2 things. The first was the number of electrons which are available, that is the number of free electrons. Obviously, that also depends upon the distance that the electrons have from the positively charged nuclei. As such, the number of free electrons which are there in different substances is different, right? This concentration of free electrons is what helps in increasing the easy passage of the electrons. As such, they being less, right, then the resistance is going to be more, right? And that is the reason why we have good conductors and bad conductors. Those substances which have a greater concentration of electrons, that is the free electrons, like if we talk about metals like copper, silver, aluminum, lead, etc., they are considered to be good conductors of electricity because they have a greater concentration of free electrons, right? The second factor which is to be discussed in nature, that is when we talk about the specific resistance or the resistivity, is the time taken between 2 collisions, right? So if the time taken between 2 collisions is more, that means the electrons are able to pass through easily, right? This is represented by physical quantity which is represented by tau, that is the time interval between 2 collisions when the electrons are moving from lower potential to a higher potential. The next, children, is the length of the wire. Now, the resistance of the electrons passing from lower potential to a higher potential, that is, the external resistance, is directly proportional to the length of the wire, right? Longer be the wire, obviously longer will be the passage of the electrons from the lower potential to a higher potential. As such, the number of collisions will increase, right? And thus the external resistance is directly proportional to the length of the wire. Now the second is the third is the area of cross section. The area of cross section is on which the resistance of the wire is inversely proportional, right? That means greater be the area of cross section, less will be the resistance. Now I showed you like this, that if suppose we talk about the area of cross section as all of these wires which take electrons from lower potential to higher potential are cylindrical, right? And if the wires are cylindrical, then obviously the area of cross section will be circular, right? So you can have a wire which, say, has a circular cross section like this, or you can have a wire which has a circular cross section like this. The one which has a greater area of cross section will have lesser number of collisions, as the same number of electrons will be able to pass through more easily with less number of nuclei falling in front. But if you talk about a wire which has a lesser cross section, then obviously the electrons which are moving from lower potential to higher potential due to the difference in potential will have more number of collisions, as there will be more positively charged nuclei which will fall in their way. Now lastly, we talked about temperature. Now, as you know that temperature is average kinetic energy. So if the temperature is more, then the average kinetic energy of the moving electrons will also be increased, and as their temperature will be increased, their average kinetic energy will be increased. As such, there will be more collisions, as they will start moving more randomly, and when their collisions increase, then obviously what will happen is, due to their collisions, the external resistance will also increase. So these are the different factors on which the electrical resistance depends. So I'm sure now you people must have understood what external resistance is, what are the different factors on which the resistance depends, and now children, you'll be able to prepare this topic well. So in times to come, in the next turn, I'll meet you people again, and I'll be discussing more topics about current electricity. Till then, revise all of this, read this from your textbooks, and prepare physics really well. Bye children, have a nice time, enjoy your lives.